Okay, thank you. Since I'm the last speaker, I think you've heard a lot this day, and I'm the last speaker from the Sunrise Pack, and so I'll be speaking to you. Okay, basically just a small introduction about myself. I'm Sheunesu Makura. I'm doing my PhD at the University of Pretoria, PhD in computer science. So basically what I'm going to discuss with you and what I wrote about this paper is on digital forensic readiness in the cloud, harvesting digital information in operational cloud environment, leveraging ISO IEC 27043 guidelines. I'll just give you a brief introduction, but that's an international standard. I was making use in the research. An outline of the presentation, very short, since I have a limited time. So we're just going to have a small introduction, look at the problem statement, and then some main ideas of this research paper. Organizations, as you all know, your Facebook, LinkedIn, Oracle, Amazon, they all make use of these cloud computing services. However, the use of cloud computing services and unwrapped many opportunities for usage of the cloud computing services. However, these cloud computing platforms have been under attack. So there's been some security concerns even from these organizations regarding these security attacks. So because of these security attacks, it then creates the need to how we can secure our data, the data in the cloud. So that's where we come with digital forensic, specifically digital forensic readiness. I provided just a introduction or a definition of digital forensics for those who don't know. It says that it's a process of using scientifically demonstrated techniques in the collection, preservation, analysis, and presentation of digital evidence obtained from electronic devices to reconstruct events that appear to be criminal. So in the traditional digital forensic investigation processes, it's quite easy to perform a digital forensic investigation because you have access to the electronic device. For instance, let's say a criminal perpetrates any cyber criminal activity using a flash drive. A digital forensic investigator can simply go and seize that flash drive, make a copy, then perform the normal digital forensic investigation process. But now when we look at cloud computing, where an organization like Amazon might have data centers sitting across many geographical locations, it becomes difficult for now the digital investigator to know, okay, where do I start from here? Do I start here in South Africa and then have to fly to America and get more copies of the evidence and things like that? So that's where digital forensic readiness now comes into play. I provided also a definition of digital forensic readiness as the capability of a digital forensic investigation agency, increasing the usage of collected digital evidence while forensic investigator to perform the digital forensic investigation easily. Okay, looking at the problem statement. So there exists no formal structure for conduct, as I was been saying regarding the cloud environment. So there exists no formal structure for conducting digital forensic readiness in a cloud infrastructure. Actually, there lacks a structured approach for conducting this without the need to adjust or change the existing cloud structure. Now, this adjusting is expensive and costly, not only for the organization, but even for whoever will be performing the digital forensic investigation. So the ISO AIC 27043 is an international standard, as I was saying. Because of the limited time, I'm not going to delve too much into it. However, basically it provides us with guidelines in performing incident investigation, specifically those incident investigations that will involve any electronic evidence. Okay, so going to the main ideas. So what we managed to do was to develop a prototype which we implemented in an operational environment, specifically OpenStack. OpenStack is actually open source cloud computing or cloud operating system. So what we did was to implement this prototype in OpenStack. In essence, the prototype is presented as a forensic agent, making use of some of the botnet characteristics, like a botnet being like a network of softwares where they can communicate with each other and extract digital information which you can then store. However, our prototype, though it mimics the functionality of botnets, it is deployed into the OpenStack in a non-malicious fashion. So this prototype, it actually prepares the operational cloud environment to be forensically ready for the digital forensic investigator. When the digital forensic investigator comes, they can do their investigations without any problems. Okay, of the prototype into the OpenStack cloud infrastructure. Then in step 2, what happens is the digital information the prototype extracts. So in this case, just as a proof of concept, is just going to, it extracts the CPU usage, RAM usage, and keystrokes. And then step 3, 4, and 5 are mainly for evidence storage. So whatever evidence is being collected by the prototype. By the way, the prototype, we called it the digital forensic evidence collecting system. So this prototype, once it collects the digital information, it hashes it to preserve integrity, and then it gets stored. We used MySQL to store the digital information, and then also on the other side, on number 5, you can actually see what the prototype extracted. Okay, so these are some of the results which you would see. This is just actually a screenshot from the, I'm not sure if the ones at the back can see this, but this is some of the information which was extracted by the prototype from many multiple instances of the cloud instances which were hosted on OpenStack, and these all are coming to a central location. So once a forensic investigator, let's say an incident happened or a security breach happened in that cloud, the forensic investigator can actually just come to these results and then use the results to find whatever might be relevant or which might assist in the digital forensic investigation process. Okay, in conclusion, the research use guidelines mentioned, as I mentioned before, in the ISO ISC 27043 international standard, which is also used in investigation processes. And it also, the prototype aligns to these processes, which is very important so as not to compromise the integrity of the data, because if you are to proceed to prosecute whoever, if you manage to identify the person, there is um, it's actually important to ensure that there's integrity and availability and confidentiality of the data is maintained. So that's why we try to make sure the prototype adheres to that, and at the same time